Hello, good afternoon. Aita. Hello, start. Hello, good afternoon, my dear students. Today I am going to teach about. Hello, good afternoon, my dear students. Today I am going to teach about the cerebellar peduncles. Already you know about the cerebral peduncles. I think I taught you in the last class. It is coming in the midbrain. Can you, anybody recollect this one? The cerebral peduncles, it is present in the midbrain. They are, it is made up of tegmentum of the midbrain, substantia nigra, and the crus cerebri. All these three parts of the midbrain forms the cerebral peduncle. But today, I am going to teach about the cerebellar peduncles. What did it say? Okay. So, what are the cerebellar peduncles? In this diagram, you are seeing, so these are the fibers. You can see the fibers here. These are the fibers of the cerebellum, and these are the afferent and efferent fibers. They are bundled together and they form the cerebellar peduncles. And there are three cerebellar peduncles are present. First one is superior cerebellar peduncle. Second one is middle cerebellar peduncle. Third one is inferior cerebellar peduncle. They are named according to their position. Superior is above, middle is middle, and inferior is present inferior. Okay. So superior cerebellar peduncle, this is the one. Okay. This is the middle cerebellar peduncle, and this one is inferior cerebellar peduncle. Superior cerebellar peduncle, it connects the cerebellum with the midbrain. So cerebellum is removed here. What you are seeing is the floor of the fourth ventricle, and this is the midbrain. I mean, this is here. You have got the pons, and here this is the medulla. Okay. Superior cerebellar peduncle, it connects the cerebellum with the midbrain. And middle cerebellar peduncle, it connects the cerebellum with the pons. So this is the one. Okay. And inferior cerebellar peduncle, it connects the medulla with the cerebellum. So this is the medulla oblongata and cerebellum, it is connecting. So first let us learn about the inferior cerebellar peduncle. So in the diagram you are saying, so this is the inferior cerebellar peduncle. Okay. So it connects the medulla oblongata with the cerebellum. So it is also called as restiform body. This is also called as restiform body. So location of this inferior cerebellar peduncle is posterolateral aspect of the upper half of the medulla oblongata. So this one, posterolateral aspect. So here you got the fasciculus gracilis ending in gracile tubercle, fasciculus cuneatus ending in cunate tubercle, and lateral to that you have got the inferior cerebellar peduncle connecting the, it is present in the upper half of the medulla oblongata. What does it contain? It is mainly made up of afferent fibers of the cerebellum. It is mainly made up of the afferent fibers of the cerebellum. So these afferent fibers of the cerebellum, they enter the cerebellum from the spinal cord. So spinal cord is below. From the spinal cord, they will enter into the cerebellum. They also arise from the olivary nucleus. Already we studied olivary nucleus. From there, the fibers will go to the cerebellum, and next reticular formation of the medulla oblongata. So all these, from all these parts, the afferent fibers will enter into the cerebellum, and as well as vestibular nuclei and nerve. From these nuclei and from this vestibular nerve, the fibers will enter into the inferior cerebellum through the inferior cerebellar peduncle. And it also consists of very few fibers, very few efferent fibers, few efferent fibers of the cerebellum that are going to the medulla. Mainly it is made up of afferent fibers from all these parts of the central nervous system. So what are these afferent fibers in the inferior cerebellar peduncle? So in the diagram you are seeing this is the inferior cerebellar peduncle. So first one is anterior external arcuate fibers and stria medullaris. So this is the arcuate nucleus, right and left. So from this arcuate nucleus, the fibers will arise and they will enter into the inferior cerebellar peduncle and they will go to the cerebellum. So these are the fibers. So these are called as anterior external arcuate fibers. Next, posterior external arcuate fibers from ipsilateral accessory cuneate nucleus. So in this part of the CNS, you can see the accessory cuneate nucleus here. Okay, so the fibers are arising from the accessory cuneate nucleus and they will go to the inferior cerebellar peduncle and enter into the cerebellum. So these are also called as cuneo-cerebellar fibers. Cuneo-cerebellar fibers arising from the cuneate nucleus, accessory cuneate nucleus, ipsilateral. Ipsilateral means same side. From the same side of the accessory cuneate nucleus, they arise and they will go to the cerebellum. So these are called as cuneo-cerebellar tracts. Next, third one is posterior spinocerebellar tract. So spinocerebellar means they are arising from the spinal cord. So from the spinal cord, they will ascend upwards and they will go to the inferior they join the inferior cerebellar peduncle and enter into the cerebellum. So these are the posterior spinocerebellar tracts, and they arise from the ipsilateral thoracic nucleus. So already you studied about thoracic nucleus. Okay, and this column is called as, this bundle of nerve fibers is also called as Clark's column. Okay, so they are also part of the inferior cerebellar peduncle. So next, fourth one is olivocerebellar fibers arising from the inferior olivary nucleus, that is contralateral, opposite side of the inferior olivary nucleus. So this is the inferior olivary nucleus. So from here the fibers will enter into the cerebellum through the inferior cerebellar peduncle. Next, parolivocerebellar fibers, they arise from the opposite medial and dorsal accessory olivary nucleus. They arise from the contralateral medial and dorsal accessory olivary nucleus. Okay, they are also joining the inferior cerebellar peduncle. Next, sixth one is vestibulocerebellar fibers. So from the vestibular nucleus, so this is the vestibular nucleus in this diagram. So from here the fibers will go to the cerebellum through the inferior cerebellar peduncle. So the vestibulocerebellar fibers, they will start from the vestibular nerve and medial and inferior vestibular nuclei. Okay, and they will end in the cerebellum. And lastly, one more group of fibers, that is reticulocerebellar fibers. From the reticular formation of the reticular nuclei, of the medulla oblongata, which is present in the reticular formation. The fibers are arising and they will enter into the cerebellum through the inferior cerebellar peduncle. So all these are the fibers, afferent fibers, which are present in the inferior cerebellar peduncle. So in this diagram, I will show you. This is the inferior olivar nucleus. So from here, the fibers are arising. So these are the olivocerebellar fibers, and this is accessory olivar nucleus. So from here, olivocerebellar fibers are entering into the inferior cerebellar peduncle, and this is the vestibular nucleus. So from here, vestibulocerebellar fibers are going to the cerebellum. Then they are the part of the inferior cerebellar peduncle. So now coming to the efferent fibers. So inferior cerebellar peduncle, it has got few efferent fibers. So what are these? There are mainly three types. One is cerebello-olivary. That means from the cerebellum to the olivary nucleus. So this is the olivary nucleus. So from cerebellum to the olivary nucleus, you have got one bundle, some fibers. They are the efferent fibers. Next, cerebello-vestibular fibers. So some of the fibers, they are coming out of the cerebellum to the vestibular nuclei. Okay, they arise from the ipsilateral flocculonodular lobe. Today morning you have studied about flocculonodular lobe. Okay, so from there these fibers are arising, and fastigial nuclei of both sides. These fibers are arising and they will end up in the vestibular nucleus. So that's why they are called as cerebello-vestibular fibers. So lastly, cerebello-reticular fibers. So some of the fibers, they are arising from the fastigial nuclei of both sides. Okay, they will go to the pontine and medullary reticular formation. Okay, so they will go here. So they are also efferent fibers which are present in the inferior cerebellar peduncle. So now let us move to the next cerebellar peduncle, that is middle cerebellar peduncle. So in the middle cerebellar peduncle, only afferent fibers are present. Afferent fibers of the cerebellum present, no efferent fibers. That point you should remember. It may be asked as a MCQ also. Only afferent fibers are present in the middle cerebellar peduncle. So what are these? There are two types. Most part of this middle cerebellar peduncle is formed by pontocerebellar fibers, and very few fibers are ceratogenic fibers. Ceratogenic fibers. So pontocerebellar fibers, as the name itself suggests, they arise from the pontine nuclei. Pontine nuclei. Okay. They arise from the contralateral basal pontine nuclei, with a small addition from nuclei in the pontine tegmentum. Okay. So from these pontine nuclei, the fibers will arise and they will end up in the cerebellum. And the location of this pontocerebellar is most laterally placed. And this middle cerebellar peduncle is largest of three peduncles. The largest peduncle is middle cerebellar peduncle. It passes obliquely from the basal pons to the cerebellum. Okay. So very few fibers are present in the middle cerebellar peduncle. Apart from pontocerebellar, they are the ceratogenic fibers. These fibers, they arise from the raphe nuclei of the pons, and they will go to the cerebellum. So this is about the middle cerebellar peduncle. So middle cerebellar peduncle is largest of the three cerebellar peduncles. So now coming to the superior cerebellar peduncle. Superior cerebellar peduncle. So it includes both afferent and efferent fibers. It emerges from the anterior cerebellar notch. Morning you studied where the cerebellar notch is present. Okay, so this is the superior cerebellar peduncle. So this forms the lateral boundary of the upper half of the fourth ventricle. So this is the floor of the fourth ventricle, floor of the fourth ventricle, and this is the upper half, this is the lower half. So this superior cerebellar peduncle, it forms the lateral boundary of the, as you are seeing in the diagram, it forms the lateral boundary of the upper half of the fourth ventricle. It contains mainly efferent fibers and very few afferent fibers. So these efferent fibers, they arise from the dentate nucleus of the cerebellum, and they will end up in the red nucleus, and they will go to the thalamus, and they will go to the cerebral cortex of the opposite side. Okay, so these are the efferent fibers from the cerebellum. Okay, they are also called as dentatorubral fibers, dentatothalamic fibers. Okay, so let us study in detail. So afferent fibers present in the superior cerebellar peduncle. Ventral spinocerebellar fibers. So spinocerebellar means they arise from the spinal cord. Okay, they are the ascending fibers. They form the ascending tract. Okay, from the spinal cord, they will ascend upwards. Okay, they will enter into the cerebellum through the superior cerebellar peduncle. Okay, actually it should come like this. Okay, so next, tectocerebellar fibers. Tectum, where do you get tectum? It is present in the midbrain. Okay, so from the tectum of the midbrain, these fibers arise and they will end up in the cerebellum. Okay, so tectum mainly from the superior and inferior colliculi of both sides of the tectum. These fibers arise. Next afferent fiber is triseminocerebellar fiber. So these fibers arise from the superior sensory and spinal nuclei of the trigeminal nerve, and they will end in the cerebellum. Next, cerebellocerebellar fibers. They arise from locus ceruleus, and these are the noradrenergic fibers. And hypothalamic cerebellar fibers are also present in the superior cerebellar peduncle, and they arise from the hypothalamus, and these are the cholinergic fibers. So now we'll study what are the cerebellar afferents. So afferents are mainly received by cortical neurons. You know the cerebral cortex. So this is the cerebral cortex. Afferents, they are mainly received from the cerebral cortex. I think we skipped this one. Efferent fibers of the superior cerebellar peduncle. Sorry. Efferent fibers of the superior cerebellar peduncle. So these are the efferent fibers. What are these? They arise one of the nuclei of the cerebellum, and they will go to the different parts of the central nervous system. So what are these? Cerebello-rubral fibers from the cerebellum to the red nucleus. So these are the fibers, cerebello-rubral fibers, and they arise from the globose and emboliform nucleus of the cerebellum, and they will end in the contralateral red nucleus. Contralateral red nucleus. Okay, these are the cerebello-rubral fibers. Next, dentatorubral and dentatothalamic fibers. So they arise from the dentate nucleus of the cerebellum, and they end in the red nucleus, or they end in the thalamus, one of the nuclei of the thalamus. Okay. Next, cerebello-olivary fibers. They arise from the dentate nucleus, and they will end in the opposite inferior olivary nucleus. So these are the fibers. So these are the cerebello-olivary fibers. Next, cerebello-reticular fibers. So they arise from the nucleus fastigius and pass to the reticular nucleus. So from here, nucleus fastigius, they will end in the reticular nuclei. So now we'll study the cerebellar afferents. Okay, they are mainly received from the cerebral cortex. So in this diagram you can see, so this is cerebellar cortex. The cerebellum receives the fibers from the cerebral cortex. So these are the afferent fibers. However, sometimes vestibular fibers and collaterals from afferent fibers stimulate intracerebellar nuclei directly. So vestibular fibers and their collaterals, they also stimulate the some intracerebellar nuclei. These afferents are mainly classified into two types. One is climbing fiber and second one is mossy fiber. So what are these climbing fibers? The fibers arising from the inferior olivary nucleus and they will go to the cerebellum. So these are the olivocerebellar fibers. Okay. Contralateral inferior olivary nucleus they arise. That means from the opposite inferior olivary nucleus they arise and they will end in the cerebellum. So these are called as climbing fibers and they will synapse with the Purkinje cells. They will end in the synaptic junction. They will make synaptic contact with the Purkinje cells, these climbing fibers. And rest other fibers which are entering into the cerebellum, they are called as mossy fibers. Other than olivocerebellar fibers, all other afferent fibers of the cerebellum, they are called as mossy fibers. Okay, and these mossy fibers, they are involved in the cerebellar glomerulus. Cerebellar glomerulus. So afferent tracts. So they arise. Already I mentioned you. They arise from the cerebral cortex. They are either directly they will go to the cerebellum from the cortex, cerebral cortex, or they will in the middle they will end, and from there again they will start. So first one is corticopontocerebellar fibers. Next, cortico-olivocerebellar fibers. Next, cortico-reticular cerebellar fibers. So this is from the cerebral cortex. So corticopontocerebellar fibers. So you can see here corticopontocerebellar fibers. Okay, and cortico-olivocerebellar fibers. So cortico-olivocerebellar fibers. Okay, and cortico-reticulocerebellar fibers. Okay, so they are also afferents. They are also arise from the spinal cord and end in the cerebellum. So what are these? Dorsal spinocerebellar fibers, ventral spinocerebellar fibers. They arise from the spinal cord and they will ascend upwards and they will go to the cerebellar cortex, and cuneo-cerebellar fibers. From the vestibular nuclei, vestibulocerebellar fibers, they will enter into the cerebellum. It also receives afferents from tectum and red nucleus of the midbrain. Okay, so all these are the afferent fibers from where they originate. So in this diagram you can see, so these are the, so this you can see here. So these are the fibers, afferent fibers, and these are the descending efferent fiber. And here also you can see the afferent fiber here. Okay, so this is okay. Afferent cerebellar pathways. Pathway is first one is corticopontocerebellar pathway. So the function of this pathway is it conveys control from cerebral cortex. So it controls the cerebellum. Okay, and they arise from the frontal, parietal, temporal, and occipital lobes, and they will end in the destination is cerebellar cortex via pontine nuclei and mossy fibers. Okay, so in this diagram you can see here. So some of the, yeah, this is the one. This is the pons. Okay, so like this is the cortico-ponto cerebellar fibers. So this is the pontine nuclei. So next pathway is cerebro-olivo-cerebellar pathway. So it conveys control from the cerebral cortex. Okay, so they arise from the same lobes of the cerebrum, frontal, parietal, temporal, and occipital lobes, and they will end in the cerebellar cortex via inferior olivar nucleus and climbing fibers. And these are called as climbing fibers. And next pathway is vestibular nerve. Okay, it conveys information from head position and movement. Okay, these fibers, the vestibular nerve, they arise from the utricle and sacral and semicircular canals, and they will end in the flocculonodular lobe, cortex of the flocculonodular lobe of the cerebellum via mossy fibers. Cuneo-cerebellar fibers. The function is it conveys information from muscles and joints of the upper limb, and they arise from the muscle spindles, tendon, organs, and joint receptors via mossy fibers to the cerebellar cortex. Cuneo-cerebellar fibers. Next pathway is cerebro-reticulocerebellar pathway. They conveys control from the cerebral cortex. So these are originating from the sensory motor areas of the cerebral cortex, and via reticular formation they will end in the cerebellar cortex. They control the cerebellum. Okay, anterior and posterior spinocerebellar tracts. They convey information from muscles and joints. They arise from the muscle spindles, tendon, organs, and joint receptors via mossy fibers to the cerebellar cortex. Other afferents, they arise, the function is they originate from the red nucleus and tectum from the midbrain, and they will end in the cerebellar cortex. Next, coming to the cerebellar efferents. All efferents are given by intracerebellar nuclei. They will start from the intracerebellar nuclei. Already we studied. However, few Purkinje cell axons of flocculonodular lobe may project directly to lateral vestibular nuclei. Very rarely from the Purkinje cells they will start. So what are these pathways? Fastigial vestibular. So this function of this pathway is influences ipsilateral extensor muscle tone. Origin from the fastigial nucleus, mainly they end in the ipsilateral and to contralateral lateral vestibular tract to ipsilateral motor neurons in the spinal cord. So in this diagram you can see this is the fastigial nucleus of the cerebellum. Okay, so from here they will go to the vestibular nuclei, and from here again they will start and they will end in the spinal cord through the vestibulospinal tract. So this is via vestibulospinal tract. They will end at the ipsilateral motor neurons in the spinal cord. So next pathway is fastigial reticular. It influences ipsilateral muscle tone. Origin is from the fastigial nucleus, and they will end in the neurons of reticular formation, and they will end in the ipsilateral motor neurons of the spinal cord via reticulospinal tract. So in this diagram you can see, so this is the reticular formation cerebellum. They will start from the one of the nuclei of the cerebellum. They will end in the reticular formation. From here reticulospinal tract will start, and this will end at the motor cells of the anterior horn of the spinal cord. Next, globus emboliform rubral. So it influences the ipsilateral motor activity. The origin is from the globus and emboliform nucleus, and they will go to the contralateral head nucleus. Then via crossed rubrospinal tract, they will end at the motor neurons of the spinal cord. So in this you can see, this is the emboliform nucleus and this is the globus nucleus. You can see here some of the fibers, they will end in the red nucleus, and they will cross the opposite side. That means they will go to the same side of the emboliform nucleus, and they will end in the motor neurons of the anterior horn cells of the spinal cord. So this is one pathway, globus rubrospinal pathway. This is globus and this is emboliform rubrospinal pathway. Next pathway is dentato-efferent cerebellar pathway. So here the pathway name is dentato-thalamic pathway. It influences ipsilateral motor activity. Origin is in the dentate nucleus, and they will end in the contralateral ventrolateral nucleus of thalamus, and then to the contralateral cerebral motor cortex via corticospinal tract, crosses midline and controls ipsilateral motor neurons in the spinal cord. So origin the dentate nucleus. Go to the contralateral ventrolateral nucleus of the thalamus. They will go to the thalamus. So this is the dentate nucleus. They will go to the contralateral thalamus. Okay. Then to the contralateral cerebral motor cortex. So contralateral, from thalamus they will go to the cerebral cortex via corticospinal tract, crosses midline and controls ipsilateral motor neurons of the spinal cord. Then again from the cerebral cortex, these fibers descend. These are the descending tracts, corticospinal tracts, and they will end at the motor neurons of the spinal cord and control the activity of these neurons, ipsilateral control of the motor neurons. Okay, this is dentato rubro-thalamo corticospinal pathway. So these are, so now coming to the clinical anatomy of the cerebellar peduncles. So there is one term, that is cerebellar syndrome. So this, what is cerebellar syndrome? The cerebellar lesions occur due to trauma, vascular occlusion and tumors. Because of these reasons, cerebellar lesions will occur in the cerebellum. So as a result, there are so many signs and symptoms are produced in the body, and all together is called as cerebellar syndrome. Okay, what are these signs and symptoms? Truncal ataxia. The patient is unable to walk properly. He is swaying either way. Okay, and staggering gait. Gait is abnormal. Nystagmus, oscillatory movements of the eyeball. Two sideway movements of the eyeball. It's called as nystagmus. Dysmetria. Morning you studied. The patient is not able to judge the distance of the object. That is dysmetria. Next, intention tremors. This is also one of the symptoms. Then adidacokinesia. So all these symptoms together called as cerebellar syndrome. Next, muscular hypotonia and ataxia occurs in some of the cerebellar lesions. Actually, dorsal and ventral spinocerebellar and cuneo-cerebellar tracts, they carry the signals or information which will help in the unconscious coordination of the body. So, if any lesion occurs in these tracts, the patient will get the muscular hypotonia and ataxia. And CP angle tumor, this is cerebellopontine angle tumor. So, this angle is present between the cerebellum and the pons. And the tumor, okay, and these tumors at the CP angle cause the hearing loss, tinnitus, vertigo, headache and diplopia. Okay, so this is due to the involvement of the vestibulocerebellar tracts. Okay, with this I'll conclude today's session. Now we'll go to the questions of this topic. So short essays of 5 marks. You will get the first one is cerebellar peduncles. You have to describe over the cerebellar peduncles. All 3 cerebellar peduncles you should describe. And second question is inferior cerebellar peduncle. In this you have to parts connected. Inferior cerebellar peduncle parts connected, fibers passing through the inferior cerebellar peduncle. Next, short answers. Name the tracts in the inferior cerebellar peduncle. Okay. With this, I'll finish today's topic. Thank you. It's a timer.